what is our topic? Donovan, what is our topic?
Free will.
Free will. What about free will are we currently discussing? What did we spend all class on Tuesday talking about? You can look at the questions from the in-class assignment. Chloe, what questions? We're trying to figure out whether determinism is true or not. Again, how are we defining free will, at least for now, our working definition? What is it? Agency, which we are characterizing how?
Like directing one's thoughts and actions.
Directing one's body, one's thoughts, yeah? Is through one's mind, more specifically, what in the mind? Our choices, our decisions, right? That's how we're understanding agency. That's how we're understanding free will for now. We talked about why we believe in it, why we think it's important, et cetera, et cetera. Then what do we need to do? We need to ask whether there might be any reasons for thinking we don't have it. We spent some time looking at arguments why we do have it. Now we got to spend some time looking at arguments why we don't have it. What's the major argument against free will? Determinism. It's been the main argument against free will for over 2,000 years. For about 2,000 years now, over 2,000 years, people have been wondering whether determinism would defeat free will. What is determinism? It's at the bottom of the handout I gave you last week. How are we defining determinism in this class? That's question 3. Victoria, do you want to answer it? You can just read from the bottom of that handout if you have it on you. Gabriella? Yeah.
The laws of nature together
Perfect. Right? What's a simple way we can break that down in the slogan form?
the event or outcome has a cause.
Okay, and that's what Sider said, right? That's Sider. And again, that is a simplification. There are some issues with that. That might help you, though, still a little bit. If we want to try to break it down in a way that's even simpler but doesn't run into the problems that Sider's definition runs into, exact same input, exact same output, right? So again, why might someone think determinism threatens free will? And again, I'll just remind you, I don't. If scientists prove tomorrow that determinism is true 100%, a lot of philosophers would say, we learned there's no free will. A lot of the rest of us would be like, that's awesome, we proved free will. And again, I know that probably sounds bananas. We'll do that next Tuesday. I just want to remind you, I actually don't think determinism threatens free will at all. So at the end of the day, for me, it really doesn't matter what science says. We're free no matter what. It's like good news no matter what. We're awesome no matter what. But a lot of other folks aren't going to see it that way. Why not? Why would a lot of folks think that determinism threatens free will? And by the way, I want to be really clear on something. Even though I myself don't believe that determinism threatens free will, I don't think it's silly to think that. I think it's smart to think that. We don't have to think that everything we don't agree with is just foolish or something. No, of course not. There's really, really smart philosophers and scientists who believe that if determinism is true, free will can't exist. And sometimes I wonder, maybe they're right. I used to think that myself. My position changed, but sometimes I wonder, maybe I'm wrong, maybe they're right. We're just trying to do our best here. It isn't like a competition, right? It should be fun, actually, right? You feeling the fun? Gabrielle, you're feeling the fun. You feel the joy, the adventure of exploring these ideas, right? It's a little bit of a trick. I mean, it does matter, but we also got to learn how to sit a bit lightly to it, right? Right? Wouldn't you agree? Yes, of course you'd agree. All right, so why would somebody think that determinism threatens free will? Yeah.
It negates effort.
Okay, good. Now, I want you to say a little more. I think this is a really nice start. Actually, we should go into that a little more. Actually, let's do that now. Let's not just put that off, right? There's a group of philosophers called the Stoics. Have some of you heard of the Stoics? A lot of people on YouTube are really into the Stoics. I say be careful what you hear about the Stoics on the internets, because it's not always reliable. And by the way, the Stoics are a bit difficult to figure out what their views were, because there were a lot of them This is a movement that lasted for hundreds of years in the ancient world, and we've actually lost a lot of their writings. So they didn't all agree on everything, and actually we've lost a lot of their writings. It doesn't mean we can't work them out at all, but it is a little bit tricky, right? It is a little bit tricky. Stoics are really popular today, largely, I think, because a lot of them taught that it's possible to master all of our negative emotions, to completely conquer them. And if we're wise and good, we will never feel any negative feelings whatsoever. And actually, if we do feel any negative feelings like sadness, you're not only a fool, you're evil. When I say the whole thing, it doesn't sound quite so attractive. I think a lot of people are really attracted to this today. I don't think they like hearing the last part. They like the first part. It's possible for us to master all of our negative emotions, so we never have to feel anything negative. Does anyone see why this might be attractive to so many folks today? Anyone see why this might be attractive to so many folks today? Kaylee? Do you know why might this appeal? My guess is, it probably appeals more to young men than it appeals to young women. Why do you think this might appeal to so many folks, and maybe in particular young men? If I come across a video on YouTube telling me if I just follow these teachings, I'll never have to deal with another negative emotion again. Why might that be so appealing? Yeah. Think back to the happiness unit. All right. Why might that be so appealing? Do you want to phone a friend?
Yeah.
Okay, pick a friend from class. You could call on anybody. Put them on the Victoria. I want to Kaylee put someone on the hot seat. All right, Victoria. Why do you think this might be so appealing?
Emotion could be seen as a weakness.
It could be seen as a weakness, shameful, bad, and plus they are tough. We really can feel overwhelmed by this. We often want shortcuts, easy ways out. Well, that could sound pretty attractive, right? All I got to do is apply these teachings. I'll never have to suffer again. I gotta be. What do you think my own view is on this? Now, so again, as a Christian, I can't go with this. I think that destroys the Gospels. I think I'd have to say Jesus is evil, right? Because he clearly experienced some hard feelings, right? The Stoics would actually say Jesus is evil, and he'd say he's a fool. Can't go for that. If I think Jesus is God, I cannot go for that. I also would just say from the point of view of modern psychotherapy, I'm just not a big fan of this, right? There have been some other traditions out there that have offered similar results. I think a lot of times they're probably much better for people than following Stoicism. That's my own view on that. If you have a different view, well, obviously not everyone's going to agree with me on that. And I get that. I understand that. That's how it is. Maybe what we could do is we could look at things we might have in common. Could it be that we could mitigate at least some of our negative emotions? Maybe. Even there, a lot of therapists would say careful. Once we put that negative label on emotions, we start engaging in the whole resistance game. But there might be some stuff we could learn from the Stoics. And here's another thing I want to say, and I know Mark wanted to raise his hand. Even though I don't really like their ethical theory very much, I think in many ways they were utterly brilliant philosophers. And I think they had a lot of really interesting things to say about a lot of topics. And so, by the way, if I encounter a philosopher, I don't agree with them on one thing, I don't say I've got nothing to learn from this person. There might be a whole lot we can learn from. Again, I want to try to get us out of this kind of rigid, okay, some people, Hitler, I'm sorry. I don't think that dude's got a lot to offer me. You know what I mean? I'm kind of done with him. You know what I'm saying? Someone might say, no, but you should read his poet. Nope. Nope. But there's a lot of, you don't have to agree with somebody 100% to agree with them maybe 80%. Or maybe you don't agree with them hardly at all on one thing, but you might on something else. And I think when it comes to free will, actually, the Stoics got something really brilliant to say about the type of objection to determinism that I think you're alluding to, because a lot of these Stoics, they were determinists, but they also believed in free will. And they were really good, I think, at coming up with responses to objections to their compatibilist position. We'll go over one in a minute. Now, Mark, do you want to challenge me on the... It's okay, but I'm not a guru, I'm not all-knowing. Things I say about this could be wrong. Would you want to challenge,
No,
not in the name of the Stoics, but in the name of something else, maybe?
I think you can overcome negative emotion,
Mhm.
but I don't think it's a resistance thing. I think it's a letting go thing. But
Okay.
but I don't know.
There might be better or worse ways to go about it.
I sent you an interesting article from a neuroscience
Okay.
perspective. Yeah, on meditation.
Okay, cool. Yeah. Right. And by the way, I'm not trying to say either that I think we can't make any progress on this stuff at all. Right. And yeah.
The interesting irony you said about Christianity, though, is that I'm not a Stoic. I don't align
Yeah.
with Greek Stoicism, or Roman Stoicism, or what have you. But most online Stoics are also Christian.
Yeah, to me, I'm sorry, that makes no sense to me.
I think it doesn't make sense.
It doesn't make sense. Even John Calvin, one of the architects of the Protestant Reformation, said Christianity is not Stoicism. If you're a Stoic, you really need to say that Jesus was stupid and evil. That's really what their position entails. It's not a good thing for a Christian to say, right? But it is what it is. You know what I mean? I don't know how much of the Stoicism that we find online too really matches up with the text very well, right? There's often a pretty big gap between these sort of things, right? But it is what it is. If you're really curious about that, you know, Stanford Encyclopedia, we looked at that. They have a really nice article there on Stoicism. You could read through that. But yeah, again, you could say, why would the Stoics say Jesus was stupid and evil? Because he experienced suffering and he experienced negative emotions. That would be, they would describe as negative, that they would describe as negative, right? The cross doesn't make any sense on Stoicism. Maybe it doesn't on American Christianity either, right? But it's supposed to be the heart of the gospel. Anyhow, this isn't, Sunday school time, so take my New Testament class if you want that. All right, so, okay. The Stoics defended this causal not exactly maybe like us, and maybe they didn't have a notion of a law of physics quite like we have today. There's some debates on that. But the Stoics we'll just describe them as causal determinists. So they thought every single event that occurs is causally necessitated by antecedent external events, ultimately. We'll put it like that. They might not use exactly that language, but that's basically what they thought. So they basically thought if you make a choice, that was necessitated by prior choices, and maybe that by prior choices, maybe that by prior choices. But at a certain point, that's going to be necessitated by stuff going all the way back before your birth, all the way back to the Big Bang. I mean, obviously they know about the Big Bang, but you know what I'm saying? All the way back, all the way back, all the way back, all the way back, all the way back. And so they would say your choices are utterly inevitable. So when you go to Chipotle tonight, right, and you get a veggie burrito bowl, right, that choice was already inevitable given the Big Bang, once you know about that. And they said you're still free. And actually, I agree with them on that. I think Stoics are right about that. And but one objection that they took to this is, well, if that's true, though, if my choice was inevitable from before I was born, then why bother doing anything? This was sometimes called the lazy argument against determinism or determinism plus free will. The argument kind of went like this. There were people in ancient Greece debating this 2,000 years ago. And by the way, when they call these people ancient Greeks, some of them came from places like Egypt and other things too. They weren't all just ethnic Greeks, but they conducted their debates in Greek, right? So they would say things like this. Look, suppose I'm sick. Well, if determinism is true, then either I'm going to get better or I won't, no matter what. So it doesn't matter for me to go to the doctor or take medicine. I'm just going to get better or I won't. My choices are utterly irrelevant. And so all agency just kind of dissolves because there's no reason for even make up my mind or do anything about that. I think the Stoics actually had a really good objection to this argument. Can anyone think of what it might be? I think this argument fails against determinism. I think it fails against deterministic freedom. It certainly doesn't show determinism's false. It could just be determinism's true anyhow, and life has no meaning, and we're all screwed, right? That could be. But they wanted to argue that even if determinism is true and we have free will, which they agreed with both, they said this objection fails. That we don't lose our agency. We don't lose the meaning of our agency on determinism. Can anyone see why? Is it true that if determinism is true, we're just going to get better no matter what? Or fail to get better no matter what? Is that what determinism says? Chris is right. It doesn't. That's fatalism, not determinism. Determinism would say it could be that if you get sick, it could be that the laws are such that You will only get better if you take the medicine. If you take the medicine, you will get better. If you don't take the medicine, you won't get better. That could be determined. It would also be determined whether you're going to go to the doctor or not. It would be determined whether or not you're going to take the medicine. That like law connecting getting better and medicine, that stands. Again, determinism runs through normal causes. This is kind of thinking the Final Destination movie series. You know what I mean? Where just stuff just is fated to happen no matter what. On determinism, everything runs through the causes. So everything that we think, it works the way we normally think it does, right? It's just that was the one inevitable outcome. But it's not a foolish objection, even though I think the Stoics gave a really good response to that argument. It doesn't mean it's a bad argument, right? I think actually it's a very intelligent argument to think of. But in philosophy, we're benefiting for over 2,500 years of doing this stuff. You know, that's a great advantage, I think, of taking these kinds of classes. You get the benefit from the wisdom of all these other people that lived. You know, sometimes it takes us like 1,000 years to work out an argument. Well, once we got it, we got it. Anything else? Go back again to cider. If we're hypnotized, does it seem like we're free? Matt, does it seem like we're free if we're hypnotized? No, right? Determinism is like hypnotism on steroids, right? You made the choice, but again, it was inevitable. If all of our choices are inevitable because of stuff that's completely outside our control, well, then it looks like they're not real choices at all. So again, what is we're going a little long on a review here. So what do we want to do? We want to know whether determinism is true. So what do we have to do that? We have to look at our scientific theories. So what scientific theories are we looking at, y'all? Kaylee, what scientific theories are we looking at? Were we looking at on Tuesday? Sorry? Okay. Alejandro, you were here? Chris, what scientific theories were we looking at on Tuesday?
Gravity, no?
We're going to talk about gravity in a hot second. Before that, what did we talk about? We kind of ended on that really quickly. But what did we talk about before that? Quantum mechanics, right? And now again, why are we talking about quantum mechanics? What is quantum mechanics? Let's review question number 4 real quick. Yeah, it's the study of atoms and their parts, atoms and their subatomic parts. Like you could just say microscopic particles, microscopic, too small to see, right? We'll actually start with atoms. We'll start with atoms and their parts. It actually turns out it's not just atoms and their parts, but we're going to start off with that, atoms and their parts. Why do we want to look at this? Why do we care about atoms and their parts? Because again, if free will for now is agency and that's directing our body with our choices, what connects atoms with our choices? Because again, we think choices come from what? Our brain, right? And what's our brain made out of? It's made out of atoms. Now again, you might start asking about the soul. We'll deal with that later, okay? I think the soul actually is not going to help at all here unless you also believe in God. I think if you believe in God and the soul, you're good, but maybe God, even without the soul, could get you out of this. And God, I think God actually does solve a whole truckload of philosophical problems, and I think it's actually not a half bad reason to believe in God. At the end of the day, I would go for other reasons, but actually God does a lot of work in philosophy. Then, of course, you got to ask yourself whether the God hypothesis makes a lot of sense philosophically, and you're going to get some debates on that, obviously. So, all right. What does quantum mechanics say then? Is it determined or not? Claudia, what did we say about this on Tuesday? Nicole? No, neither of you were here. Actually, I remember that. I was doing the tennis afterwards. I'm like, wait, neither of them were. Yeah, I knew that. Gabriella, what did we? Okay. Sarah, what do we say? What does quantum mechanics say? You can watch the video if you weren't here, because I'm not going to go through the whole thing again like I did, but I do want to repeat. Yeah? What do we say?
There's like a mathematical formula which can determine how future particles or atoms will interact, and therefore you can discern what choices will be made in the future.
So here is the deal, right? We'll look at this again really quickly. And you could look at the Cider article. Again, I'm just reviewing stuff so far. And I could send you, I'll upload the videos and send you the links. Again, if we look really quickly at this article, we actually spent a lot of time on this on Tuesday. This is just the intro paragraph from this article on quantum mechanics by Janan Ishmael. She starts off by saying quantum mechanics is a mathematical machine, or we said mathematical tool, mathematical theory for predicting the behaviors of microscopic particles. She says the math is well understood. And we've tested it experimentally, and so far it holds up extremely well. She then goes on to say, though, that nobody knows what the theory is actually about. Why? Because, again, we have different interpretations of the theory. Do you all remember this from Tuesday? Here's the long and the short of it. We have different interpretations of the theory. Some interpretations do uphold determinism, but many give us indeterminism. And again, if you remember, we talked a little bit about whether we should read the Bible literally or not at the end of class. This is all an oversimplification. Is quantum mechanics deterministic or not? I think the answer is nobody knows, really. Why? Because scientists don't agree. How do we know that? Because they have different interpretations of it. And some actually give us determinism, and some give us indeterminism. Again, I told you guys in class, and it's true, a lot of physicists will actually tell you determinism is false. They will just tell you it's false. And we saw that. We read from this book by Steyer, who is himself a physicist. And what did Steyer tell us on page 2 of his book? He said determinism's false. Why? Because quantum mechanics. That's actually how a lot of scientists talk. A lot of scientists talk as if determinism is just false. I was actually looking at some stuff today on double slit experiments. The double slit experiment. There's actually a variety of them. And this is produced by a physics professor at the University of Durham. And I could send you the link to this. It'll just run you through the basics of double slit experiments in quantum mechanics. And it kind of just tells you at the bottom, we must abandon the idea that an electron has a definite position at all times. Instead, we may only predict the probability to measure the position. The laws are inherently probabilistic. That's just what this physicist told you. And then he just drops his mic and he runs out the room. This is how physicists often talk today. They just will tell you the laws are probabilistic, not deterministic, and they drop their mic and they just run out of the room. And I think there's a real danger in this. Actually, I think in a way this is highly irresponsible for scientists to write like this. Because if you don't do a lot of physics, or you don't talk to a lot of physicists, it's so easy to think that the scientific community has basically proven determinism is false. Do you kind of see what do you see what I mean by this, right? Remember we looked at all this stuff on Tuesday over this, right? It's so easy to think that. Actually, I got the book right here. I'll quote again. This is from our buddy Steyer, right, page 2. And again, this guy's a physics professor. He's not a philosophy professor. He's a physics professor. And what does he say on page 2? Quantum mechanics is probabilistic. Even in the presence of exact knowledge of the current situation, it's impossible to predict the future. That's what he tells you. He never mentions once that not all physicists agree. I'm actually shocked by this, but a lot of scientists do this. They will just kind of ignore a number of their colleagues and just tell you the one position like it's true. But we do this thing in religion a lot too. We do this in a lot of places. We just ignore all the positions that we don't agree with. We just pretend they don't even exist. But I think the reason why they get away with that so much is because so many that is kind of the way they think about it. Right? I did this in my other class. I kind of played a little trick on them. I won't play the trick. It's really easy to trick people into believing in determinism, by the way. I think I kind of did it to you guys a couple weeks ago. See if this sounds good to you. See if this jogs anything for you. What language do we use to write up the laws of physics? Well, you could say English, Italian, whatever. What language is this?
Math.
We write it in the language of math. And now I say that, and everyone just goes, uh-huh. And then I say, okay. If we take 1 and add it to 1, how often do we get 2? How often does 1 plus 1 equal 2? 100% of the time, or only 99% of the time, or it's like 100% of the time? Well, then it's got to be determinism. You can convince a lot of people with that argument. It's not a very good argument, actually. Be careful on the internet. People messing around with this type of stuff. It sounds good, though, doesn't it? 1 plus 1 always equals 2. Math's always 100%. We write out the laws of physics and math. How can that argument be flawed? If I take a 6-sided die and I roll it, what are the odds that it's going to come up as 6? 1 in 6. I told this to my class the other day, and it's true. I've seen this firsthand because I used to play a little bit of craps in the casino. All right, I got some verification for this. If you walk up to a craps table, there's a roll. Why am I teaching you this? Okay, there's a roll called boxcars. It's double 6s. It's a one-time bet. You have to put your money down on the table, and then whoever rolls next, if it comes up double 6s, you get paid. If it doesn't come up double 6s, the very next roll, you lose your money. I've actually hit on this thing multiple times, and I was smart enough to never go back to the casino. At least I didn't play craps. Anyhow, what are the odds that if someone rolls a pair of dice, they're going to come up 2 6s?
136.
Yeah, 1 over 36. Isn't that math? It sure is. Does that mean whenever I roll a pair of dice, I'm always going to get double 6s, or I'm never going to get double 6s? It's the math of probability. That's how the laws of quantum mechanics are actually written. And that's why these scientists, so many of them, will just say, it's not determinism, it's probability. That's it. That's what Steyer said. That's what that says. You just go look at just Google 100 web pages on quantum mechanics this weekend, written by physicists, and probably close to 100% of them will just tell you what I said, and they'll just stop. This guy, you start reading, and again, he's another physicist, you start reading him, he doesn't tell you to like page 44 that there's even another option out there. If you just read the first 2 chapters of this, you'd come away with the same view, but eventually he gets around to telling you, yeah, not everybody agrees. Not everybody agrees. And then you might say, well, wait a second, if you tell me that these laws, like this, these equations are probabilistic, not deterministic, how on earth could anybody get determinism out of this theory? Because they'll basically say the theory's missing something, and you got to add in this extra stuff. We call these hidden variable theories. And when you add in the extra stuff, then you get determinism. But the reason they're called hidden variable theories is because we don't have solid evidence for that extra stuff. And so a lot of scientists I just don't have reason to buy that. And when you start looking at the arguments over what makes a good interpretation of quantum mechanics, to me it's so philosophical and also scientific, this crazy, crazy mixture. And the bottom line is I think we just don't really know. Chris, did you have a question?
Oh yeah, I was just going on about the probability you were saying, like 1 in 36, like saying that if you roll a dice 36 times, you're guaranteed that one of those.
No.
But that's not true.
No, it's not. It's not true.
Because you could and you might not.
You might not. And that's actually a really important point too, because one thing we haven't chatted about is some people are going to say that even if quantum mechanics is true and it's not deterministic, we still wouldn't be free because we'd be slaves to the quantum mechanical probabilities. This is what Sider says, but actually that presupposes that frequency equals propensity, which it doesn't. So that's actually a very important point that we're going to want. I actually want to deal with that next Tuesday. But you're absolutely right. You're absolutely right. That's actually a really important point for us too. If we make little mistakes here about probability, it can really kind of hang us up. And again, you could say, what does it matter? Because we're talking about our freedom here. We're talking about whether we got free will. You got to be really careful again on the internet. And again, people on the internet, if they got some nice facial hair, at least if it's a man, if they got, if someone's got a nice beard and they got a nice thick pair of glasses, and they wear a little suit, you might just believe anything they say. Careful. By the way, I think you all should maybe freak out a little bit by the fact that so many scientists just talk as if determinism has been proven wrong. By the way, I would like for determinism to be proven wrong, because even though I believe it doesn't threaten free will, it sure, I think, makes things easier to defend free will. If it turns out to be false, I mean, I could have played tricks with you. I could have just walked in here and quoted 3 scientists and said determinism's false, therefore we got free will and left. Let's not do that. We want to be as honest as we can. We don't want to take any shortcuts. We don't want to make things easier for ourselves. We always want to ask, could I be wrong? Could I be wrong? Could I be wrong? Right? I'd be a little worried if I were you guys. I've given you evidence here that a lot of scientists will just kind of play fast and loose and not give you the full facts. What do you think you could do if you were interested in questions like this? Do you think you could trust the first website you read? Mark, can you trust the first website you read?
No.
Could you even be sure if you consulted 3 you're guaranteed to get the truth?
No.
I've given you 3 scientists already that just make it sound as if quantum mechanics is proven determinism is false. What's a question we could, suppose we went and talked to a number of physicists and we said, what does physics say about determinism and indeterminism? And the first 3 all said, well, I think it shows determinism is false. What's one good question we could ask to try to make sure we're not missing anything? Honest, does anybody disagree with you? Would all your colleagues agree with me? Is there anybody in the field that disagrees with you? And if so, who are they? Right? You know what I'm saying? I mean, this happens too this happens a lot with religion. You know, you might find someone who says, here's this passage in the Bible means this. Does everybody agree with that? This passage in the Quran means this. Does everybody agree with that? Buddhism claims this. Does everybody agree with that? Hinduism claims this. Does everybody agree with that? Because again, a lot of times people will pass off their interpretation as the absolute fact. I'm not trying to say, and by the way, I'm not trying to say I think it's all relative and nobody really knows. I think for a lot of things, there are really, really good interpretations that really should command our assent. I just get worried about when someone's trying to twist us into something. You know what I mean? That's where I get worried about it. All right, so 4, 5. So let's just go through this again. Question number 4. Let's answer this together. We're going to do 4, 5, and 6, and I'm going to put you in groups. We haven't done 6 yet, but I want to put you in groups. What's question number 4? Let's do this as a class. This is going to be a bit repetitive today. How do we answer question number 4? Chris?
Mathematical theory for predicting the behaviors of microscopic particles.
Boom. All right. And why do we talk about it when we talk about free will?
Because our brain is made up of atoms. And
Yep.
if we just relate to quantum mechanics.
Free will, choices. If our choices are determined, at least a lot of us are going to think we're not free, that our choices aren't free, that we're not free. Again, you can challenge that, but there's a lot of people who believe it, and it's not, again, it's not a foolish thing at all to believe, even if you don't agree. There's reason to think that if our choices are determined, then they're not free. So then, if that's right, we want to know whether our choices are free. Our choices come from our brain, setting aside the soul. Well, then we want to know what science says about our brains. Are our brains determined or not? To do that, we'd want to look at scientific theories about the behavior of atoms, because atoms make up our brain. I could have done it a little more smoothly, but that's how it goes. You can sort of work that out. 5, is quantum mechanics deterministic or indeterministic? What do we want to say about this? Kaylee? Yeah, I'd say we don't have a proof. You could say we don't know for sure. We don't have a proven answer either way. You want to go a little further and say we have different interpretations of the theory. Some interpretations uphold determinism. Others give us indeterminism. And scientists just don't agree on which interpretations are correct or which interpretation is correct. Right? My sense is far more physicists actually take it not deterministically, take it indeterministically, but I don't want to I wouldn't want to go on a record with that. I'd have to go talk to some more folks. What about classical physics, aka Newtonian physics? Do you remember what we said about this? Is that deterministic or not? Yeah.
You said it was not fully deterministic. It's largely deterministic.
Yeah, it's widely believed to be fully deterministic, but actually it's really not. A lot of scientists talk about it as if it's fully deterministic, but it's really quite not. Again, it's not totally, and why does that matter? Because it's, a lot of people have this idea that physics 200 years ago was totally deterministic, and today it's totally not. Those are both actually oversimplifications. Those are both oversimplifications, right? All right, question number 6. We're gonna watch a little Star Wars. And I'm gonna break you into groups. All right, a little bit of background. Empire Strikes Back. What series does this belong to?
Star Wars.
Star Wars. Okay. Empire Strikes Back. What do you all know about it? I mean, it is the greatest film of all time. That is an objective fact. There's no disputing that. Definitely the best Star Wars film. I think maybe the best film of all time. All right, maybe you got Princess Bride in the mix. Okay, so what is the what is the backstory here? Does anyone know? Who's this dude hanging from the ceiling?
Luke Skywalker.
Oh my, thank goodness, someone can answer that. This is Luke Skywalker, okay? He has been captured by this Wampa, this kind of like ice monster, who's gonna snack on him, right? Now what he did is he kind of stuck Luke to the ceiling by icing his boots, and Luke is gonna wake up and realize the monster's coming after him, and spoiler alert, he's gonna successfully defend himself, okay? He's gonna pull this thing into his hand. What did Jedis use to fight? Lightsaber, like light sword, right? Okay. He's gonna use this thing called the Force, all right? Which you all are familiar with, yes? Okay. He's just learning this. He's still struggling with it. Return of the Jedi, he's a boss, right? But here he's just kind of struggling with it. So that's why it takes him a little bit of time. All right, so it's a little gruesome. Then he runs outside and kind of passes out in a snowstorm, and Han Solo has to come save him. All right, so he used the Force to draw the lightsaber to his hand. I grew up around Chicago. When I was a kid in the 80s, we would all, our parents would take us to Jewel, and we'd all stand outside the door and try to use the Force to open the door, right? Does the Force strike you as more like science or magic?
Magic.
Yeah. Yeah, it looks more like magic, right? Why? What is it about it that looks that's so magical? That act of him pulling the lightsaber in his hand. I mean, I still every once in a while, like at home, because I mean, I watch these films 10,000 times. Every once in a while, I'll still like, do I have the? I'll like try with like a cereal bowl or something. It's like, yeah, it doesn't work. Why does it look like magic? Yeah.
Because it defies physics, gravity.
I'm so glad you said it, and I'm so glad you said it like that. It looks like it defies gravity. Okay. This theory, we're on question number 6 now. This theory of gravity that we have, well, actually, we got a new one actually from Einstein. But it was really Sir Isaac Newton who gave us gravity, or universal gravitation. Again, he died in 1727. Let's actually see what AI says. Who discovered gravity? Let's see if AI gets it right. Sir Isaac Newton, right? It's true. He came up with it, at the end of the 1600s. It's really an amazing thing. You could say, well, wait a second. This guy hasn't even been dead 300 years yet. How is it that he discovered gravity? Like, no one before saw this, and actually people before did see this. And sometimes in Latin, they called it gravitas. but it wasn't gravity. And you're like, well, why wasn't it gravity? Yeah, Chris, have you talked about this in the class before?
Physics.
Okay, what they say? Why do we say Newton was the first person that came up with gravity? I mean, there again, even Galileo. We say Galileo didn't know about gravity, but he did talk about gravitas, which just means heaviness, right? He used this Latin term, gravitas.
He just gave it a definition for the act of it being like pulled down, but Newton was the one who actually figured out like science behind it.
He figured out the math behind it, right? Yeah, he figured out the math. He gave us these equations, right? Yeah, Kaylee, you talk about this? Sorry?
I was just gonna go off that, like he discovered, like from the apple, so he used that, theory, and then, use like the force of pressure, he got hit by the apple or something like that, and that like kind of made him more aware of like gravity and force.
Okay, yeah. You could ask this question too then. Yeah, I mean, it's great you guys talk about this in some of your classes, right? You can ask, what did people before Newton, what did they think? Well, if we go back to Aristotle actually argued there were 5 different types of matter, 5 basic types. One was earth and water, and then fire and air, and then he thought there was one up in the heavens. Why am I drawing it like this? Aristotle noticed that if you drop a handful of dirt, it falls down. If you light a match, where does the fire go? Does the fire go up or down? The fire goes up. Air goes up, fire goes up, earth goes down, water goes down. He also noted, like if you put like a stone in a bucket of water, does the stone float on the water or go to the bottom? Goes to the bottom. So what he thought was basically each kind of matter, fundamental kind of matter, had its own laws of motion. That each thing had its own laws of motion that were kind of inherent to it. And it was the nature of fire and water to go down, and the nature of air and fire to go up. And that like fire was like lighter than air because it would go up through the air. And earth is heavier than water, and so that's why the stone would go to the bottom of the bucket. It's a really smart idea. I mean, we know it's not true now, but in his own day, it was actually really brilliant. And then when it came to the heavens, he thought that they were made out of a 5th element, and that they didn't go up and down, straight up and down. There's like a fancy word for this, rectilinear, right? They didn't have natural rectilinear motion. They had natural circular motion. And why did they think that? Because the sun just looks like it's going around in a circle. The moon's going around in a circle. The stars are going around in circles. He said if like earth, air, fire, and water go straight up and down, and that stuff goes up in circles, right? Then that stuff must be made out of a fundamentally different matter than anything we have on Earth, because it's got a different natural motion. So he called it a 5th element. Not a lot of people actually bought that argument, but he went for that. And things like this kind of survived for a long time. And then Newton was the one who actually figured out that the same force that brings this down to the desk, this is the same force that's keeping the planets in orbit around the sun. Right? Oh, this makes me think of this Wu-Tang song. I keep planets in orbit. Anyhow, so it's like one force that keeps planets in orbit. It's the same force. And then, of course, you'd have to explain, well, why are the planets going around in a circle instead of just going like this? Why? The planets don't just fall, right? Yeah. They don't just fall. They're going around. They're going around in circles. Why? What's keeping the planets going around in circles? Chris?
The pull from
The pull from what?
the mass of the planet.
And what's pulling them? What are the planets going around? The sun, right?
Yeah.
The solar system. And that's why we call it that, the solar system, right? Because the sun is pulling the planets around it. Okay? How far away is the sun? Does anybody know? I think it's like 8 minutes, whatever, for light to get here. It's like 93 million miles away. That's how far away the sun is. Now, you said, Chris, and hey, I agree with you. I think we're all going to agree with you. When we watch Luke Skywalker pull up the lightsaber, you missed some stuff. So, we watched Empire Strikes Back. Now, when Luke Skywalker pulls the lightsaber, we're like, that looks like magic. It defies gravity. Some people say, too, you can't, like, I can't, there's nothing I can do right now to make the marker come to me. If I touch it, then I can move it. But if I don't touch it, I can't make it come to me. The sun's 93 million miles away from us, and it's pulling us around it. And when you start to think about that, gravity starts to look a lot like magic. Do you know what I mean? Newton's equations of gravity tell us that for any two masses in the whole universe, they exert a gravitational attraction on one another that is proportional to their masses and inversely proportional to the square of the distance between them. That's just a really fancy way of saying that the more massive you are, the more gravity you exert on other things, but the farther away you are, the weaker your pull is. Right? The sun's 93 million miles away. Then how on earth can it pull, how on earth does it pull the earth around it? Because it's a million times like bigger than the sun. Sorry, the sun's not a million times bigger than the sun. It's a million times bigger than the earth. It's way more massive than the earth. It's way more massive than the earth. That's how it's able to pull everything, including Jupiter, around it. Does this kind of make sense to y'all? This theory actually is pretty wild. This theory is actually saying, I guess we believe that there's a supermassive black hole, Sagittarius A, at the middle of the Milky Way. If Newton's theory of gravity is right, your left kidney is actually pulling that black hole towards Earth right now, but just a little bit. And it's pulling you towards it, but just a little bit. It's kind of freaky, right? Doesn't that kind of sound like magic? When Newton came up with this, a lot of people said, "You're nuts. Like, what have you been smoking?" He's like, "Nothing." I don't know if that had all been invented yet, right? He's like, "Nothing." But people thought it was crazy. They thought this theory of gravity is crazy because they called it action at a distance. In other words, they said, your theory, Newton, looks like the sun would be pulling us toward it from 93 million miles away. How does it do that? That's freaking magic. That's what they said to him. They said, that's freaking magic. They said, if you can tell me a story, if the sun is over here and Earth is over here, if you can tell me a story that the sun is acting immediately on something that's touching it, and that's acting on something that's touching it, okay, I don't want to do that all the way over here. Right? And you could do that, then I'll buy your theory. Otherwise, it's freaking magic. And I don't believe in magic. And Newton's official response was, shut up. His official response is, read the math. His official response is, it works. I'm not going to tell you what gravity actually is. I'm going to give you the math, and I'm not going to tell you what it is. And I don't know what it is, and it doesn't matter what it is. The math works. Use the math. Okay? This is actually the exact same position we're in with quantum mechanics right now. That's why I wanted to make this analogy. That's where we're at with quantum mechanics. We understand the math. We don't know what it's really about. By the way, Newton, when he was with his buddies, like drinking at the pub, he actually had a bunch of different theories of how gravity worked. He just didn't want to like officially say one was right because he didn't feel like he had enough evidence for it. But one of his theories, wait for it, is God just added it to the universe. All right? Yeah, that was a theory of gravity that a lot of scientists went for. Actually, when they got convinced. They're like, where does it come from? They called it like a super added property because they thought God had to add it in because it just struck them as so bananas. Like that could only come from God. Like you can't even make sense of gravity without God. I can't use the force to pull the marker into my hand. Only God could explain that. But I think it's an interesting question whether you might need God to explain laws of nature, period. Which actually, I kind of favor that view myself. So anyhow, but we're not going to get into that right now. They might be post-Thanksgiving. But his official papers were just, I don't know. He actually had this really fancy Latin phrase, non fingo hypothesi, which basically meant I'm not going to pretend like I know. I'm not going to feign a hypothesis. I'm not going to like venture an explanation because I wouldn't have enough knowledge behind it to like demonstrate it. All I'm going to tell you, this is the math. Read it and weep. And again, why am I running through this story with you? Because actually, I think it's super fascinating. But also because I think it does explain why we're in this position we're in with quantum mechanics. Does that make sense to you? This could be our situation with gravity. We could kind of realize the equations work without knowing what it really is. Does this kind of make sense to you? We could be in that kind of a position. Does this make any sense at all? We might be able to like observe something enough and extrapolate some math from it, which is just actually noticing the patterns, but without really knowing what's driving the patterns. Marco?
I hear like when they were, constructing the table of elements, like there were gaps.
Yeah.
They theorized there were elements that were there, but they couldn't discover them yet until they did. Yeah.
Right. And actually that's something that helped Newton out, because people were like, okay, if this theory is right, then that comet we saw a couple years ago, we should see that again in a couple of decades. And boom, it showed up. There's this story, I don't know if it's totally true, but it was, I think it was Hubble. No, not Hubble. Hubble's modern. My bad. Halley, the guy we named the comet from. That's got mixed up. Halley. I think it was Edwin Halley. Edwin, I think is his name is. You guys heard of Halley's Comet? I think it was that Halley. There's a story that he went to Newton's house one day, and Newton's maybe chilling in his dressing gown or whatever you do as an English gentleman back in the day. And he actually asked him if you're basically like if your theories, it was something about what shape should. Actually, I might be getting a little mixed up now in the story. Maybe I'm telling it wrong. But the way I think I was remembering it was basically Newton revealed that like if my equations are right, and like the sun it has the mass it does and the planets have the mass they do, we should expect them to trace out elliptical orbits around the sun, which is actually the shape they do trace out. The planets actually don't move in perfect circles around the sun. They trace out elliptical orbits around the sun. This comes from Kepler's laws of planetary motion. Right, Newton's theory explained that, and it predicted a whole bunch of other stuff. A lot of gaps got filled in. We actually used this to discover the planet Neptune. We used this theory. We kind of looked at the planet Uranus, and we saw that its orbit is kind of weird. It's kind of off. It's kind of funny. And then we said, well, if Uranus is actually moving the way we think it is with their telescopes, and Newton's theory is right, there's got to be another planet out there. And then Leverrier just was like, okay, I'll know where to look for it. Ah, there it is. We discovered a planet Neptune off of this stuff. It's pretty dope. All right. Again, the whole point of this is to help you appreciate how we could actually get the math right without knowing what gravity really is. Right? And actually, Einstein gave us a little, explanation of what gravity is, and I mean, who knows? I mean, we're going to probably keep refining this in years to come. All right, so here's what I want you to do. I want to break you into groups, and I want you to share your answers to 4, 5, and 6 with one another, and see if you're all on the same page, and see if you feel like you understand it. I want you to discuss it with one another and see if y'all feel like you understand it, and see if you could come up with any other questions. Any other questions about free will and determinism that maybe we want to address before we move on? Okay? All right. Sarah 1, Donovan 2, Bella 3, Ann 4, Nicole 1, Claudia 2, Coldeep 3, AJ 4, Gabriella 1, 2, 3, 4, Chris 1, 2, Victoria 3, Chloe 4, Kaylee 1, 2. So I'll do 1's over by Sarah, and 2's can hang out here where Coldeep is, and 3's will be here where Eric is, and 4's will do over here. I'm gonna run to the restroom real quick, but basically just get in your groups and just ask yourselves, did you understand any of that stuff we just talked about? And see if you're all basically on the same page with the answers, if it all makes sense. If anybody feels like they're not totally solid on what this is all about, see if somebody in your group, if you guys can kind of explain it to one another and work it out, okay? Actually, just focus on that for a minute, and then I'll give you something else to do when I come back. All right. Peace. Go ahead and explain. Marco, you're in charge.
Okay.
Hold your responsible.
All right. Somebody.
Gravity, then freaking. Got to do with quantum mechanics.
Mysterious stain on my seat.
And that has something to do with free will. I'm talking about gravity. I'm not gonna lie. Because we're answering 4, 5, and 6.
The thing is, you gotta read the homework.
Quantum mechanics.
Yeah.
I'm only missing one more round. I did do the last one.
Was it athletes?
I think it's.
If I recall, it was, I think philosophers, most of them started.
That one was short though, which is amazing. I have it like half done
Deterministic
because
because.
I wish you would go to like question
Understand
like they did today,
basis
kind of.
that it gives multiple options.
Yeah.
Therefore, it's not
It hasn't done that
one
previously.
thing.
So you gotta watch like 3 hours of videos.
Yeah.
Yeah, I've done the last couple. I usually just put them at like 2 times speed, or like just like go as fast as I can through them. And usually, well, the last one he was like questions one thing, what have you, or in this video, and then the other questions are through that one. But I think mine is really good. Should get more straight too, so we can make it easier for us later on. So, like, you guys have any questions?
Which one? Oh,
I think we haven't done 7 yet.
When Newton published his theory of gravity, many scientists and philosophers were concerned about it. Its apparent postulation attached to the distance.
You just kind of said this, but I don't
I
think
think
you
that
have
means like,
answering questions.
its claim.
No.
Yeah, like, let's go with someone. No, I think that means like.
So, 6, when Newton published his theory of gravity, many
Postulation of
scientists
action
and
at
philosophers
distance.
were concerned about its
What does
apparent
he think
postulation
is
action at distance. Why? They
I don't
felt
think,
it
yeah,
was
here's
like
like,
magic.
like I paused it later.
What did Newton
I'm actually pretty sure that's how it is.
the math?
What did Newton
And then
himself say?
how is this relevant to the interpretation
How
of
is it relevant to the interpretation of quantum mechanics?
We're solid on the map, but we're not sure exactly what it's for.
It's very simple.
Like the weight on the lot.
Oh my gosh.
Philosophers actually look at it and it's yeah, like myself.
So
Really?
Okay, yeah, what did it
It really, yeah, there's actually a philosopher, Michael Brown, wrote a book called
It's like, what do you think that happens? Distance?
It's really.
Yeah, what do you think about the current postulation of the distance of quantum mechanics?
He just used the equations to tell you what he's seeing, but he doesn't know what's making the patterns happen. He can just see they are happening, right? Yep. I mean, it makes sense when you put it that way, right?
Yeah, I think so.
Yeah.
I thought of it that way.
Yeah, okay, what do you got?
Yeah, so. What do you guys prefer?
Tell me what you got for 6, cause that's the one that's gonna be true.
That's what we're struggling on.
Okay, you're good, you feel like you're good on 4 and 5? Okay, then what do you got for 6? Just try.
I wasn't understanding that.
Okay, alright.
Where'd my head go?
He gave the math for it, but he doesn't understand the reasoning behind it, like what it means.
Yeah, why did people not like it? That's the first part of the question. You're good on the second and third part. The first part is,
Oh, I put in my.
what was the concern that people had about it?
Action at a distance.
Yeah. Why are people concerned? That looks like magic. It looks like magic. It's impossible. It just looked totally bananas. Again, does anybody here think I could pull like that drink to my hand from that far away?
I've seen some dudes on Instagram do it.
How can the sun pull us from 93 million miles away? It just looked like magic, right? So what did Newton, so that was the concern, is it looked like magic, it didn't look possible. And honestly, a lot of folks said the best way to explain it is just God's making it happen. Which basically meant there's nothing in science that could actually make sense of it. It's just God had to be doing it, right?
How did we define?
They thought anytime anybody like plays basketball, it's God is making all the things move around. You know what I mean? Because they just thought it's crazy. To understand it, right? They just thought like this is crazy, and that's why some people also didn't want to believe this theory. They're like, this just doesn't make any sense. It's nuts.
Is quantum mechanics more theoretical than anything else?
So here's the thing you're seeing is, so what did just to answer your question, what did he say? What did Newton say in response?
I don't know.
I know because you were here. What did he say in response? What did he himself say?
Would you guys prefer how
He
it
doesn't
is
know.
or
He doesn't know how it's working. He just knows that it works,
Oh.
right?
Did he
again,
give his
how is
opinion on it?
He did have various views on it, but he didn't publish any officially on it.
Well,
But one of them was it's just a superated property from God.
and then, do What do you guys put for
So
one?
it's just God making game mechanics and just like deciding which ones exist.
Yeah, basically, once you make that move to God, you're basically saying there's nothing in nature that could possibly explain
But,
this. It's gotta be God.
yeah.
So, right? I mean, in a way, if you think about it, like, there's a lot of folks that think whenever you perform magic, you have to be doing it through a demon. The idea seems to be that like only something like an angel or a demon can have that kind of power. Like it couldn't come from nature. That's kind of what they were saying about gravity,
I'm good.
right? Except they didn't think it came from Satan. They thought it came from God. Right. So why is it like quantum mechanics today?
Usually in a group together. Yes.
Oh, because people don't have an understanding of why it's happening, right?
We know the math checks out, but we don't know what it's
The reason.
what
No, I don't
it-
think so.
What it's actually.
You guys believe in magic?
All right, let's just do this together. I talked to two of the groups, I'll make sure we're on the same page and I'll give you something else to chew on. What is, so 4 and 5, do you all feel solid on? Okay, so 6, how do we answer 6? Chris?
Does it start?
They questioned him because of
And I think the actual.
Yeah, why were people concerned about it?
because it didn't make sense.
Yeah, because again, it does look like magic. Again, when I show you the force, you're all like, that's magic. And then gravity, you're just like, yeah, that's just gravity. Right? But again, we kind of just take gravity for granted because we're just so used to it. But when Newton came up with this for the first time, people were like, this is freaking magic. It doesn't make any sense. And again, this whole idea that God, I was just talking about the whole idea that God added it in. So, do any of you play Dungeons and Dragons? Okay, so I haven't played in like 20 years, but I've been told in the new edition, 5th edition, there's a type of spellcaster called a warlock. And I asked, well, what's the warlock? And somebody who's really into D&D said, a warlock is somebody who casts all their spells through a demon. Right? It's like the person doesn't really have the ability themselves to make the magic. It's like a demon has the ability, and they make some agreement with the demon or something, and the demon lets them cast the spells. There is some kind of tradition of that in human thinking, that if people who are doing magic, they have to be doing it through some kind of angel or demon. I'm not telling you to believe in magic or anything. I'm just trying to highlight this idea that a lot of humans have had this thought. There are certain things that just can't come from nature. Can't come from nature. Has to come from some kind of like supernatural power. That's how gravity looked to a lot of people in Newton's day. And again, a lot of them didn't say it came from Satan. They said it came from God. Anytime you threw a marker up in the air and it fell down, they're like, God had to zap that like that. So it's not just God has to like answer everybody's prayers. It's like God's gotta like make sure the gravity equations like get respected all the time. Right? Does this kind of make sense? So again, you might think God's just doing that with all the laws all the time anyhow. Or maybe God just does it with one decree from the beginning of time. Actually, there's 2 points getting better. But they thought it was magical. And again, if you think, why would you think gravity is magical? Because you think something can affect something from a distance like that, but that's exactly what gravity seems to be telling us. Unless you come up with some little way to explain how the sun is only acting on something it immediately touches, and that's only acting on something it immediately touches, and that's only acting on, do you see what I mean, all the way down? And some people said actually that's how it is working, but we didn't see what those things would be. Do you know what I mean? Some people actually, that's what Descartes' view actually was. Right? I mean, he didn't have gravity either, but Descartes actually thought that the way the sun's interacting with us is it's basically acting on little particles in between. Everything's touching. Everything's got to be touching. Right? I mean, all right. So what's the second part of the question? So what did Newton say in response? When people were like, yo, Isaac, this looks whack. Like, what was his response?
Well, he said that he doesn't have to explain it, just look at the math, that it's right.
Yeah.
Like you said, non-bingo hypothesis.
Yeah.
Maybe talking about pretend like he knows it, but the math's right.
The math works. What he's basically saying is, I don't know why it works, but it works. And like I was saying with Marcus, if you think of it like this, that what math is doing is just a way of summarizing patterns, well, certainly we can know that a pattern holds without knowing why it holds, right? That's it, actually. That's pretty damn logical. That makes a lot of sense. And we're kind of in that position right now with dark matter, if any of you have been reading about that. We have some observations. We think something's got to explain them.
So we got a whole bunch of different theories about what it is. We're not sure what it really is that's doing it, but we're pretty sure that something's out there doing some stuff, right? It's kind of positionally. All right, so what's the last part of the question? How does this relate to quantum mechanics today? Sarah? How does this relate to quantum mechanics today?
I feel like Ryan's kind of said how it was both atoms, like everything, yeah.
Okay, that's fine, yeah. Gabriella, did you?
He said that it was like Newton used mechanics of it and gave it a purpose.
Sorry?
That Newton used the mechanics of it and gave it a purpose.
He definitely had things he could use it for. Basically, we're in the same position today with quantum mechanics that Newton was in with gravity. The math works, the maths. We don't know what it's really telling us. We don't know what it's really about. This actually happens a lot in science. We kind of see some stuff happening, we're not sure how it works. Right? I mean, actually, Darwin had to go through this with evolution, right? Back in the 1850s, he published Origin of Species, but if you ask Darwin, how does a selected trait get passed on? He couldn't tell you that because he didn't know anything about genetics. That was kind of a black box for him. How does a parent pass something on to the offspring? He couldn't tell you because he didn't know about genetics. That came long after Darwin was dead. This happens a lot in science. We might know like a medicine cures something, but we might not know why. We just can see the pattern. Take this, you get better. Take this, you get better. Take this, you get better. Why? Just and then we try to figure out why.
Do you see what I mean? Does this kind of make sense? All right, what are some questions we should ask going forward now about free will? What have we basically learned? We haven't yet tried to work out whether determinism would defeat free will, but I think we can say this. No one should be saying determinism is true. They should not be saying it like that. Then again, I don't know if anybody should be saying the opposite. I think it might just be science doesn't give us a clear answer to this question yet. Do you know what I mean? What questions should we be asking next about free will? Just talk about that in your groups for the rest. I want you to give me some... And if you don't have anything for that, I just want some general philosophical questions that I can make a video on over the weekend for y'all. Because I keep sending out these emails saying, please send me questions, and nobody sends me questions. So ask, what questions do you think we should ask next about free will, or free will and determinism? Or if you're like, I don't know, just see if you can come up with some other philosophical questions you think would be kind of cool to discuss after the break.
Mr. Wolf?
Yeah.
I have a question for you.
What is it?
You know how we've talked about like awareness can like give you free will even in a sort of conditioned reality?
Okay.
But like, what about like if awareness is conditioned, then how do you deal with like that? Can you be aware of the awareness? Can you be aware that your awareness is conditioned, but then you kind of go infinitely, right? Because you're aware of that conditioning and that conditioning and that conditioning and that conditioning.
I want something easier than that. Sorry, I'm just messing with you. We'll talk about it. Yeah. If we don't do it in class, we'll talk about it in afterwards.
Okay.
All right. Come up with something else.
Okay.
Alright, what is, I don't know.
Why are we turning
I don't know, you guys come up with something.
Wait, sorry. What? That sounded really good. Try to let him break it up.
Well, I think it's an important.
Religion?
I think religion. Either you're trying to disprove religion, or and it's particularly I think it's pertinent in Western religion. I don't think people just really care. But I think the idea was, yeah. So if you say determinism, if you say free will, although I think that's
But you're talking about for everybody to happiness.
I know some people care about philosophical. People always care about philosophy, but I don't think
Well, I think it's kind of like ethics is a very
also like
And it's like science.
I think it's a law thing as well.
Right.
Yeah. People.
No, that's a huge question.
Like religion or morality.
Should people accountable or not, or to what degree, you know?
I know, that's why.
Oh my gosh,
I could get it done by like a cosmetology student and it's cheaper.
Okay.
The chicks.
Okay, I like that. Right.
I don't wanna
you
do
guys.
that.
Maybe not before they do
Yeah,
it.
$100
Others.
for one color.
I'd rather be like in my own house
Yeah.
and it's cheaper.
Is it okay?
I go on and on.
And I didn't pay.
Also, it's not, you guys gotta say stuff ever.
Have you ever taken revenge on
Can't say
someone?
everything.
Or even something just petty, just like.
Yeller on revenge? Always wrong.
Always wrong?
That's what Jesus said. I agree with him on that one. I think we get some arguments for it. Always wrong.
Oh my god, like I feel like it depends on.
Have you ever- yeah?
Yeah, like I, like, yeah.
But it wasn't like anything crazy though, right? Yeah, no, I feel like, I don't know.
I like it.
It's very
You have to
complicated.
do-
I know,
I
but
got each one.
I live in San Francisco.
Someone just take like the real.
I like my own sense of what's there.
Yes, like if my sister.
Like for example, when it comes to like making friends, friends that can use, it's like,
That's what I'm saying. I was, it's not the same.
but not, that's what I'm
So you put a burrito in the refrigerator?
I'm pretty sure.
Yeah.
People are sensitive.
You eat it
Right, I just eat it.
fresh from Tapatio, within 3 minutes of being made.
I mean, what if it's like a leftover burrito?
No, like I feel like.
You do not leave leftovers, you eat the whole thing.
I'm always just.
But there's also people say-
Okay, stop, alright, stop, we
No, but then like
can.
if it has lettuce, you can't really like.
That's true.
I think that's a-
You just gotta eat the whole thing, Jonathan, you gotta commit, come on.
I think you need like salad.
Where do you get the?
But where do you get salad?
Yeah.
I'm vegetarian and I don't eat salad.
Pizza.
Well, not like pizza. What's that?
You should do that.
It's
Cold pizza.
It's all like, obviously,
Yeah,
it's
but
all
like,
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 What?
It has a lot of sauce on it.
well, I just mean like,
I don't like sauce on it.
All right, y'all,
Standard is got-
we're having a debate about whether it's legit to put certain foods in the refrigerator, all right, to eat leftover. Anybody got any questions about free will specifically, other than that one? Anybody got any questions about free will? Haley, you had a great one, which is basically, look, we're talking about determinism coming from physics, what about from psychology? That's a fantastic question. Even if we can solve the problem of determinism for free will at the level of physics, there might, a lot of philosophers actually think there might still be some significant threats just coming from psychology. So we're gonna definitely wanna talk about that. Right, anything else? Does it make sense to actually eat salad? No, it does not. All right, what else? Anything else? All right, here's something I do want you all to chew on. I'll give you something. I'll send you an email later tonight for what we're going to do next Tuesday. I would like to be done with free will next Tuesday. We have to settle this question of what we want to do after the break. What is on the syllabus is God and religion. I kind of don't want to do that because I don't want to bother anybody too much. So if anybody has got an alternative to God for after the break, let me know. Or if somebody says they really, really want to do God. I'm afraid if I do God, I'm just going to upset all of you at some point. Right? And
Take a vote.
I want, you know, I don't like upsetting people. Anyone want to talk about God, religion after Thanksgiving? You guys are killing me. Okay, that's about half the class. It's about half the class. All right, I'll do a little in-class like survey next week. They'll be a little more official. All right, peace.